Okay, we're taking up the graphing quadratic functions worksheet, and I had asked that you complete the table of values and use them to graph the quadratic functions. I also asked that you calculate first and second differences when you're completing those table of values. So check your work with what you have compared to what I have. The first graph I've done in green, and so on the grid you will see the graph of y equals x squared minus 4 in green below. And the second one's purple, so it's graphed in purple, and the third one I've done in red, and it's graphed in red. So take a look, see how you did. One thing I would like you to note is that for all of these U-shaped curves, the first differences were not constant, and if they were, it would be a linear, not a quadratic relationship. But what you should notice is that the second differences for each one of these are constant values. So the first one had a second difference of positive 2. The third one, or the second one had so positive 2 is what we had as a constant second difference. Our second difference was also positive 2 in the part B, and in part C our second differences this time were all positive 4s. Now, key idea here, it happened to be 2, it happened to be 2, it happened to be 4, but they were all positive. So one thing we are going to note here is that whenever your second differences end up being positive, and that of course is provided that your x values are increasing, okay, and order of subtracting of course does matter. As we increase our values of x, if our second differences are positive, we will have graphs that are concave up. So the opening up graphs. So second differences will all be constant, and if your graph is opening up, those will be positive, and conversely, if the second differences are positive, your graph will open up. Next, I then listed my key characteristics. So my first graph, the green one, had a vertex down here at 0, -4, it's opening up. It has a minimum value of -4 because it reaches as low as -4 on the y and then turns around and goes back up. There are two x-intercepts at -2 and then one at, two x-intercepts altogether. One is at -2 and one is at +2. Or you could write them as an ordered pair like I did here, -2, 0 and 2, 0. And the axis of symmetry is the equation x equals 0 because it's the vertical line that passes through the vertex. For the second one, the purple one, we have a vertex at 4, -1. It's opening up, minimum -1. There are two x-intercepts, one at 3 and one at 5. Our axis of symmetry will be halfway in between those zeros. So 3 + 5 divided by 2 is 4. It's like finding the midpoint, and that concept is very important. Okay, and likewise with the green, when we had the -2 and the +2, halfway between -2 and +2 is the midpoint. The midpoint matches up with the x-coordinate of the vertex. The last graph, the red one, the vertex is at -7, -2. It's opening up, minimum of -2. Your zeros are at -8 and -6. Halfway between -8 and -6, we have our axis of symmetry, which will be at -7. So x equals -7 is where our axis of symmetry is. So what do all the second differences have in common? They happen to all be multiples of 2. They're all even numbers. There's a reason why, and they always will be for quadratics. They should be multiples of 2. In this case, they were all positive, and our second differences were all constants. So second difference is positive, the parabola will open up. And it will be a parabola when they're constant. Okay, for all of these, you should have a domain that x is an element of the reals. Once we put a story to this, like a ball being thrown up in the air, like the soccer ball being kicked, like those examples that we did earlier, we were only looking at a very specific part of the graph, and then our domain would change. But for now, when we don't have context on it, it's just any real numbers for all of these. Now our range for the green one, the green goes as low as -4, but then we're going up, up, up and away with those y values. So your y is any real number, y is an element of the reals, and y is going to be greater than or equal to -4. The second one, y is an element of the reals, it's all real numbers, except and that y has to be greater than or equal to -1. And our last one, y is an element of the reals, and y has to be greater than or equal to, because we're going upwards, and it looks like that was at -2, and that should match those should match my optimal values here. Okay, you're ready to move on to the summary that you're going to add to the back of page 6. Okay, when we look at the next group, all of these had second differences which were negative, and all of these graphs are opening down graphs. And again, our second differences are all multiples of 2, and yeah, we have our negative values indicating that they're opening down when we have our second differences. Okay, that further, if you look at your actual information down here, you can see where the vertex is for each one. These all have max values because they're opening down. We have our zeros, and our axis of symmetry is always the midpoint between our zeros. And I'm just looking at the value here. I've got a -8 and a -2 for my purple one, and halfway between -8 and -2 is -5. Yeah, that does make sense. Okay, and again, our second differences are all constant. They're all multiples of 2, and in this case, they're all negative because all of these parabolas will open down. So that brings us to some key ideas that we need to talk about and summarize. But one last thing before we do that, I'm going to talk about these last 2 columns here on both graphs. I'll start with this one since I'm already on the back side. If I talk about domain, the domain are all values that my graph uses for x. So if I look at my green graph, my vertex was up here at 0, 9, way up at the top here. My x's from there are heading out and out and out and out and out. As my graph goes down, my x's just keep heading further and further out. Okay, and likewise on this side, and I can erase this in a moment here. My x's keep traveling further and further out with my extension of my graph. So in the end, we're going to cover every single value of x that's ever possible with this particular graph. There's no restriction to my value to it at all in terms of the x values. So let me see if I can undo what I did in terms of making a mess all over my... There we go. I think that's pretty good. We're going out and out and out. So our domain for this will be any x value belonging to the real number system. And because mathematicians like to be efficient in how they communicate things, we say x is an element of, so this is the Greek letter epsilon, meaning it belongs to the set of or is an element of, and then we do the real number system. So capital R, ideally it's bold-faced, but because it's hard to do boldface, I usually just draw double lines and then my R coming off the double lines like that, and that's a commonly acceptable way to make the R. And some typefaces in textbooks will actually use the double line as opposed to boldface. Now, there is a restriction to the y values. The range are all the values of y that the graph uses. So if I look at my green graph, my y value only goes as high as 9 and never goes higher than that. And that is supported here with where I say the max is 9. So a max of 9. So in terms of the range, we can have all real numbers. We're not leaving any values out at all. We're not just saying it's the whole numbers or just integer values. We are using decimals and fractions and non-repeating decimals and terminating decimals and non-repeating, non-terminating decimals and so on. So it's every single real number except, or and, so in English a comma means and, in math it does too. So y is an element of the real number system. So y belongs to the real numbers. And we're also saying that y is going to have to be less than or equal to 9. All of the values we use for the y will be less than or equal to 9. Okay, so try doing your domain and range for the second one. Put me on pause. You try it, and then we can check. Okay, if you've tried the next one, you should have that our x will just be an element of the reals, because as we extend our graph, the x's just keep going out and out and out and covers more and more x values. For the y values, it's going to be all the real numbers, but we're putting a restriction that, and y is going to be less than or equal to, and my purple graph goes as high as 9 as well, so it's going to be less than or equal to 9 as well. Now try the red one if you haven't. Put me on pause, and then we'll take it up. Okay, your x is an element of the reals. As you extend, it will go out and out and out along the x-axis. Your y is also an element of the reals, but it has a restriction on it. In this case, the y-coordinate of the vertex happened at 3, so our y's only can go as high as 3. The y will be less than or equal to 3. So that's domain and range. Go back, try it on the other side of the sheet, and then you can take it up.